Let's talk a little bit about what our covered conductor configurations are. We have two, one on the left, one on the right. The one on the left is spacer cable. We've got on the top three heavily covered conductors supported by a messenger and separated and hung by spacers. Okay, it's got a narrow right of way. You can see it's about 12 inches side to side. California, we're using 18 inches side to side, but it's 12, 13, 18 inches side to side and top to bottom. If we go with tree wire, it's the same heavily covered conductors, but strung in an open wire configuration on cross arms with poly insulators. You can use shorter or more narrow cross arms to get a more narrow right of way, because if we have conductor clashing, there will be no current. We won't have a fault or an outage. So we did a lot studying the difference between tree wire and spacer cable as a mitigation tool, and which is better and why. Well, basically, there's no difference between spacer cable and tree wire with respect to wildfire mitigation, unless on the left, a fallen tree comes and sits across all three phase conductors, abrades that covering, creates a bare wire, and then we start throwing sparks and having a problem. So that's the difference. But the differences that arise are those related to foliage removal and tree trimming. Spacer cable uses much less right of way than tree wire, and you're saving 80% of your tree trimming, literally 80% of your foliage. But what are we to do with selecting one of these two options for wildfire mitigation for aerial covered conductor? We decided to use tree wire when there's no trees, which sounds absolutely absurd, but the concern out west is that we can have a palm frond that becomes ignited, and this palm frond can fly a half mile to a mile while still being ignited, drop somewhere else, and create a wildfire there. So now the utility is responsible for that wildfire in a new location. So we're going to use tree wire where there are no trees. We're going to use spacer cable when we have treed areas, when we want reduced right of way, when we're putting 2, 3, 4 circuits on those poles. That's the difference in strategy. We wanted to talk a little bit about the flammability issues for a covered conductor, the cable becoming overheated and igniting itself. What's the possibility of a passing wildfire igniting the cable? And what is the possibility of a covered conductor jacket igniting and carrying the flame to another area? Well, the current state of the industry is that, number one, flame retardant has not been used to date for medium voltage covered conductor. Bear Valley Electric in California published an article saying they were using FR cable covered conductor and getting some good results out of that. They did not publish what standard they tested to, and it turns out the material they're using is not even flame retardant. It's what's called flame resistant. Number two, what is the perceived need application for FR additives? Well, we're going to enjoy the higher ignition temp. Not going to be much higher, but it's going to be higher. We're certainly going to enjoy the anti-drip properties so that the cable extinguishes when the flame is removed. Problem is that the temperatures at which the wildfires exist exceed the ignition temps of polyethylenes, regardless of their plain high-density polyethylene, whether it's cross-linked high density or whether it's cross-linked high density with a flame retardant version. They will all ignite. We know that FR cable will be more resilient and less prone to ignition in the event of a passing wildfire. That's going to increase the cost of materials, but we should be looking down that road. These are some of the issues we discussed with the California Public Utility Commission years ago. What's the possibility of a cable becoming overheated, igniting itself, dropping to the ground, and creating a wildfire? Well, we have protective devices on those lines, reclosers, breakers, fuses, and we have backup protective devices that remove the circuit in case of an overcurrent or a fault. We know that ICEAS 121.733 standard for tree wire and message-supported spacer cable requires cross-link to have a higher temp rating for covered conductor. So these, again, are higher temp ratings. And lastly, we've never had a recorded incident of a protective device or a backup device protection failing to operate and igniting a covered conductor. So what's the possibility of a cable becoming overheating and igniting itself? About as close to zero as you can possibly get. What's the possibility of a passing wildfire igniting the cable? Well, wildfires usually pass quickly, especially since they're often wind-related events, leaving the covered conductor, a cable, unharmed. If that wildfire is static, if it's motionless, if there are no winds, it's just sitting underneath the power line and cooking away at 2,000 degrees Fahrenheit, well, probably everything is going to be burned, not just the cable, but all the surroundings. And again, as we said before, any and all cables might burn, whether it's HDPE, XLPE, or flame retardant mixtures. Lastly, we have no recorded incidents to date of a wildfire igniting a covered conductor.